All right, for this next example that we're going to do here, this is going to be the most common thing that you'll see in this chapter. This is, you'll often hear me call it grams to moles to grams. We're going to look for either going from grams of a reactant to grams of a product, or grams of a reactant to grams of another reactant, or grams of one product to grams of another product. And to do that, we need a balanced chemical equation. And I'll remind you again, if there's not a number there, you can go ahead and write a 1 there. And this tells me that when 1 mole of N2 reacts with 3 moles of H2, it produces 2 moles of NH3. And then in our particular problem, we're given that 34.06 grams of ammonia. In order to produce this, how many grams of N2 do I need? So I first need to get to moles. Here. 1 mole of NH3. I provided myself with the molar mass here, 17.03 grams of NH3. Now, once I have this in hand, I can use the mole ratio from the balanced chemical equation, which tells me that for 2 moles of ammonia, I need 1 mole of N2. And then finally, as the last step, since they are asking for a mass, I know that 1 mole of N2 has a mass of 28.02 grams. Now if I go through and cancel my units, moles of N2, moles of N2, moles of NH3, moles of NH3, grams of NH3, grams of NH3, I'm left with the correct units. I wanted to know how many grams of N2 I was looking for. Now I'm going to put all this into the calculator. And I won't show this on every single one, but let me do it on this one. I'm going to put everything on top. I'm going to ignore ones, of course, because those don't do anything. I'm going to go parenthesis 34.06 times 28.02, close parentheses, divided by parentheses 17.03, and then the only other real number there is 2, close parentheses, equals. And this is 28.02 grams of N2. Okay, and it's no coincidence, actually, that these two numbers are the same, because I chose a mass that was exactly 2 moles of NH3. So of course I need 1 mole of N2 to do that, and then the mass of 1 mole of N2 is 28.02.